Love you keep waiting. Today's class we'll see what is the second state of matter. That is what we used to call as liquid state, and what are the properties of liquid state. So now, if you see that, we know about like whenever I said that whenever we think about the solids, our brain immediately will think something which is very very compact or rigid or which is having a particular shape. That is what we discussed in our last class. Same way, whenever you are thinking about liquid, can you tell me what is coming into your mind? What is the picture coming into your mind?
Water.
Liquid, everybody. So whenever I say liquid state, immediately first one thing, that is what most important thing in our life. That is what it will come into our life. What is that, guys?
Water.
Water. Yes or no? So flowing water, or simply I can say water. So we can define a liquid if you take anything like, as we are thinking about water, always we will think about, we will visualize the flowing of water. So we can define liquid with the help of the flowing water. So of course you can see the flowing water or moving water always will move from one place to another place. So now, like water, those substances similar to the water who shows fluidity or which can flow, that is what we used to call as liquid state. So if you take this liquid, for example, Mr. Sanjay is having a 1 liter bottle, means in the sense of, can you tell me, Mr. Sanjay, how much amount of water you can fill in this bottle? So the bottle capacity is 1 liter. Okay. So what is the water, maximum amount of water you can fill in this? Anybody? All of you? If a capacity of a bottle is 1 liter, that is what volume or capacity. So the volume of a bottle or capacity of a bottle is 1 liter. So is it possible to fill 1.5 liter? Everybody? Is it possible to
No,
fill
sir.
1.5 liter? No. Understand? Because why? Like solids, of course, liquids having gases, gaps between them. They are having a little spaces compared to solids. They have little bit more spaces between them. But you can see liquids also almost incompressible, and you can see always the volume of a liquids is remains constant or not. Everybody, the volume of a liquids is constant or not? Please respond, everybody. Yes or no? Nobody
Yes,
answer. Yes. So that is what you have
Yes, sir.
to remember. So it is almost incompressible and they are having a fixed volume. But you can see if Sanjay water bottle is like this, some Kishore water bottle will be like this. Now again this volume also same 1 liter. Now is it both here water is appears to be different shape and here water is appears to be different shape. Some other water bottle will be like a cylinder. Now you can notice it. Is it a liquid water is having any particular shape? All of you. If I pour in this container, it is obtaining the shape of this container. In this container, in this one. If I put in this one, like this one. Is it yes or no, guys? So or else, if I go to our lab, we are having a beakers. So you can notice it. Like this beaker, have you all noticed in our lab, chemistry lab? If I pour the same 1 liter water, it will obtain the shape of this conical flask. If I put another kind of one who is having a shape like this, understanding? So now in this, if I put a water, same 1 liter, it will turns into the shape of this one. If I'm having a beaker like this, then it will obtain the shape of the beaker. So now from this, you can tell me, is there any fixed shape for liquids? All of you?
No, sir.
Yes, sir.
No.
No, sir.
Yes or no? So liquids have no fixed shape. So based upon the type of the container, they will obtain the shape. And you remember, but volume, the same 1 liter volume in this beaker, same 1 liter volume in this one, same 1 liter one in this, same 1 liter one in this bottle also, in this bottle also. So everywhere they are having a definite what? Volume. Volume is always remains fixed volume, but they do not have fixed shape. Is it right or wrong? Everybody, please respond.
Yes, sir.
All of you?
Yes, sir.
Yes, sir.
As you know, liquids having particles are having enough spaces between them. Now you tell me, particles are only vibrate to and from motion, or they can displace, like lower particles will go up, upper particles will come down. Is it will takes place or not in liquids? Yes, please. The movement of the particle. See, solids, if you take, particles are very closely packed. So only from its mean position, it will move left and right. That is what to and from motion. Is it right or wrong, guys? Everybody? But in liquids, particles are having spaces between them so that they can easily move one place to another place. Is it right or wrong? Everybody?
Yes, sir.
Yes.
Yes,
So
sir.
now you tell me, means if they are able to move from one place to another place, they have high kinetic energy or low kinetic energy compared to solids. Compared to solids, they have
They
high
have
kinetic
high
energy or
kinetic
low
energy.
kinetic energy.
Hi,
Everybody?
Karan.
High kinetic
Yes,
energy.
high kinetic energy. Understanding? So that is what you have to remember it. But you can see here, compared to solids, they are having little bit more spaces compared to solids. But compared to gases, they have less spaces or more spaces compared to gases. All of you?
Less
Less
space.
spaces.
Less spaces. Understanding? So, in order to arrangement of particles, the particles have higher kinetic energy as compared to solids. So, these liquids, the particles always will displace us, like upper particles will go down, lower particles will come up, like this keep on changing because they have high kinetic energy, higher kinetic energy compared to whom, guys? As compared to, please respond, compared to
Solid.
whom?
Solid.
Compared to solids. So that is what we
Solid.
call liquid state. So please write it. Definition of liquid state: those substances which show fluidity. Means fluidity means what? Who can flow. Understanding? So that is what the substances, those substances which show fluidity or which can flow, which can flow but are almost compressible or incompressible. Everybody? Almost incompressible. Clear, everybody? Incompressible and have a definite. Who is the definite? No definite shape, but they have what? So write the definition of fluid, like liquids. So those substances which shows fluidity. So what is the meaning of fluidity? Everybody? Means which can flow easily. Understanding? Which can flow, but are almost incompressible and have definite volume. So they are called as liquid state. So the liquids we can say. So in these liquids, the particles, they are somewhat loosely packed. Compared to the solids, the particles are somewhat loosely packed. So they are having some large spaces more than a solids. So if you notice it here, so they do not have like proper order arrangement. Suppose if you take the solids, they are having a fixed arrangement of particles. But in liquids, no proper arrangement of particles. And these particles are having greater kinetic energy or lesser kinetic energy. They are having the high kinetic energy than solids. So they can keep on moving inside the fluid. Keep it in mind, within the fluid, within the fluid, the particles will be keep on displacing from one place to another place. So that is what we used to call as liquid state. Now, so let us discuss this liquid state. What are the properties of this liquid state? So if I see some kind of substance, so in what basis I can decide either the given substance is a liquid or solid or it is a gas. So that is why we should know the properties of liquids. So we have studied many properties of solids, like they're having a definite shape, they're having a definite volume, their ability to form lattice, and they're having a little cubical expansion or thermal expansion. They are very, very highly rigid and low compressibility, negligible kinetic energy, and as well as less or no diffusion. So these many properties we studied about properties of solids. Is right or wrong? Everybody, please respond. Yes. Same way,
Yes,
coming to the liquids also. So the first property of liquids, if you take like solids, so liquids also having fixed volume, but they do not have what, guys? All of you respond. They do not
they do
have
not have fixed shape.
fixed shape. So that is
No
the
fixed shape.
first property. So no fixed shape. So if I put the water in the beaker, so they will liquid will obtain the shape of a beaker. Understand, everybody? If I put the same liquid in a conical flask, then it will obtain the shape of the conical flask. If I put a water in a container, like different kind of water bottles, you can see your shape. So same amount of water. So according to the shape of the container, the liquid will transform his shape. So that is why we used to say they do not have fixed shape, all of you. Okay, clear, everybody? So liquids have no fixed shape. Okay, write it. The liquids do not have fixed shape. The liquids do not have fixed shape. They take the shape of they're taking the shape of the whom, guys? They take the
Container.
shape
Object.
of the,
Container.
shape of
Container.
the container in which they are stored. Is it okay, all of you? Clear? Understand it? So why, guys? What is the reason behind? Anybody can tell? Because the particles are present between them. How they are? They are loosely packed or closely packed? All of you.
Loosely.
Loosely packed.
They are loosely packed
Loosely
compared to
packed.
the solids. Understanding? So that is the reason. So they are having weakly attracted. Means the force of attraction between them less than solids or more than solids? Everybody. Yes, please.
Less than solid.
Less than
Less than
solids.
solids.
And
Less than
have you
solid.
noticed it? Solids can only do to and fro motion, but liquids within the liquid they can move in any direction. Is it right or wrong? Everybody, are you all understanding? So within
Yes,
liquid,
sir.
the liquid particles can move in any direction. That is the reason they do not have any kind of fixed shape. Okay, so according to the container, they will get it. That point you should write it. Right. The particles of the liquids are weakly attracted. The particles of liquids weakly attracted and and can move within the liquid, in any direction. Is it okay, guys? All of you? Clear? Please respond. So that is what is the reason. Okay. This diagram also you can draw. I will draw one more time. So if this is the liquid, all of you remember the particles can move inside the liquid. Sorry, remember that is what within the liquid, they can move in any direction. Okay. So that is what is the liquid property. So that is why they have a fixed volume, but they do not have what? Everybody, they do not have
Fixed shape.
Shape.
fixed shape. That is what. Okay. What is the first property? Second property, again, same thing. That is what is that? Fixed volume. So we know that they are almost incompressible in nature. So they do not have at a given temperature. Understanding temperature must be constant. So at a given temperature, they are having very, very, of course, compared to solids, they have little bit interparticle spaces, but they cannot be compressed much. So that is why, as they cannot be compressed much, they are having a fixed volume or not fixed volume. Everybody, they are having a fixed volume. Clear, everybody? That is what you have to remember. So, right, the liquids have fixed volume. The liquids have fixed volume Because at a given temperature, Mr. Sam, can you understand? The interparticle space, is it particle space will changes or remains constant? Interparticle space at a given temperature. Everybody, girls, space.
Remain constant.
Yeah, interparticle space of liquids is fixed. Is it right or wrong, everybody? If the temperature increases, space will increase or not? I want to know. Temperature increases, space will increase or not? Shivani, Agalya, temperature
Sir.
increases. What will happen, guys? Space will increase or not? Space will
Increases.
increases. So that volume may change. But here, interparticular space is fixed. When it will be fixed, guys? At what? Given temperature. Understanding? So therefore, they cannot be compressed much. Almost incompressible nature. They cannot be compressed. They cannot be compressed much. Okay? Clear, everybody? Understanding? So, they have what, guys? They have a fixed volume or not? Everybody? They are having the fixed volume. Is it okay, guys? Nivedan, Lingesh? That is what you have to remember. Next. So if I put the water outside, they will stay at the same place or they will be started moving. Everybody.
Will start
Stay at same place.
They will stay in same place. For example, I'll pour
They
the
will
water
start
in
moving.
outside. Suppose this is the floor. I'll pour the water here. Is the water will be same place or they'll start moving in any one direction? They'll start never move.
Moving, sir.
They'll start moving. Understanding? That is what we can say third property. So motion of that, what we used to call? Everybody. We used to call it as fluidity. Okay. So write it. Third property of liquids. Liquids shows fluidity. Liquids shows fluidity. So what do you mean by fluidity? Anybody can tell? Yes,
Can
please.
flow.
Yes, please. What do you mean by fluidity? I already
Sir,
told.
Which can flow.
Which can flow. Understanding? Can flow easily. They are called as fluids. So liquids can flow very, very easily. So you can see that. So you can see they can flow from height to depth or from high pressure to low pressure. Always you can put it. For example, if you on the tap, if I on the tap in my restroom, you can see water will come from where? It is there in our house, somewhere above the house we are having a water tank. So as soon as if I on the tap, the water will passes from the terrace to your tap inside our tap in the pipes. So how they are passing? Because they are what? They are actually fluids. Understanding? So that is why every liquid we can say example of what? All of you fluids. Understanding? So fluids means which can flow easily. What do you mean by fluids, everybody? Which can flow? Which can flow easily. Understanding? So that is what. So what is the one of the examples for fluids, everybody? Liquids are the examples of fluids. That is what water. So as soon as if I on the tap in my toilet, so immediately water will come from the terrace where the water tank is present. So because fluids can move, water can move, water is the example of liquid, so which is having a fluidity, means they can flow. So they can pass from height to depth with the help of understanding. Always you can see high to low it will pass, or from they can passes from high pressure to always high pressure to everybody low pressure.
Low pressure.
So that is what. Now you remember. Now for example, Mr. Gokul is having immediately he will be asking for example. Let me take some other, yeah. So let me take Mr. Nivedan. Nivedan, I will give you the two fluids. One fluid is a honey and another fluid is a water. Now you tell me, if I pour 1 liter of honey and 1 liter of water, now which can travel more longer distance and which can flow easily? Anybody can tell me?
Sir, water.
Yes, please.
Sir, water.
Water.
Water. Understanding why water? Because different fluids is having different fluidity. Do you all understanding? There is no two kinds of liquids having the same fluidity. Understand everybody? Please respond. Clear? So that is because of another parameter called as viscosity. Of course, we'll study that also. So viscosity we used to call as, so viscosity means thickness. Understand all of you? Now, for example, how to measure the viscosity? So you can see viscosity means in the sense of a stickiness. So stickiness, if you notice it, if I put my hand in honey and if I put my hand in water, who can stick more to my hand, honey or water? Everybody.
Honey.
Honey.
Honey. Understanding
Honey.
that property we used to call as viscosity. Clear, everybody? So all of you remember, that is what you have to understand. So honey also can flow, but honey can travel only less distance. Less distance it can travel, and that too, the movement will be very slow or fast movement. Yes, please. Movement is very, very slow. Yes or no? But water can move faster. Is it right or wrong, guys? All of you understanding? So that is what you have to understand. So from this, I can say the fluids having same, that fluidity of a different liquids is same or different? Everybody. Different fluids
They're
is
different.
different fluidity. Very, very important point. Understand, Mr. Lingesh, Kishore? Yes, that is what. Write it. The fluidity of different liquids. Pranav, can you hear me? Liquids is different due to their different densities. Different densities. Okay. So that is what you have to remember. Okay. So if you see these liquids, again, these liquids, I can say again two types. All of you observe. So what is that means? For example, again, let me take Mr. Who is absent? Mari is not there. Who else is missing? Gokul Raj is missing. Then who is there not there? Girls. Agalya, are you there? Okay. So now observe very carefully. Ma? Who? Alfin. That's fine. Okay. Now observe very carefully, Shivani. Now, for example, I will give you one glass of water and one glass of petrol. But this is petrol, okay, and this is water. Now let me see who will say. If I kept both are in open container, both are liquids. Is it right or wrong? Petrol and water both are called as liquids or not? Everybody? Yes, please.
Yes,
Now
sir.
you tell me, if I put it outside open container, after 10 minutes, I'll come and see. Now you tell me whose volume is remains same and whose volume is less. I take 1 liter of
Petrol will
water
less,
and
sir.
1 liter of petrol.
The petrol will evaporate, sir.
Yes,
Petrol will evaporate, sir.
petrol will evaporate, but who is easily evaporating? Of course, water won't evaporate. Nivedan, water
Water.
also will evaporate, correct?
Yes,
Yes,
sir.
sir.
Yes, please.
Yes, sir.
Yeah. Yes or no? But why petrol is very fast evaporating? That is what I want.
Due to its density.
Not due to the density. Yeah, very good. So that is what is called as, some substances we used to call, all of you remember, the liquids, who can change their state easily by changing small temperature. You can see next time when you go with your father or your mother for fueling the petrol or diesel into your car or bike, you can see when the petrol is filling into the tank, you can notice surrounding some kind of a smoke like fumes are going. Have you all noticed it? Everybody? All of you? Yes,
Yes,
please
sir.
respond. You might be
Yes, sir.
notice it. Heat waves like it is passing. Next time if you are going, you can observe that. I think already somebody of you observed. Not due to the temperature. So basically petrol at normal room temperature, just for room temperature, if you expose also, for petrol, easily it can changes from liquid state to what state? Everybody? Liquid state
Gaseous
to?
state.
Yes, please.
Gaseous state.
Clear, everybody? So that kind of substances who can change their state very easily, we used to call it as volatile substances. What we used to call, all of you? Please respond. Volatile substances, and who cannot change their state easily. Suppose if you want to change the water from liquid to gas, how much temperature we have to heat it? All of you, we all knows 100 degrees Celsius. Understanding? So it is very, very more. That is why it is actually, we used to call it as non-volatile substances. I hope everybody clear with the volatile and non-volatile. So who is the example of volatile? Petrol or water? Example.
Petrol.
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 Non-volatile, water. Understand?
Water.
So who
Water.
can change their state easily by changing less temperature? That is what, by changing in the temperature very small, who can easily can change their state is called as, understanding, is called as
Volatile.
volatile. And who cannot change their state easily, who is to called as what? Non-volatile.
Non-volatile.
Understand?
Non-volatile.
Now, sir, how, sir, we can decide either it is a volatile or non-volatile? Remember, generally the liquids having high density are less volatile, and the liquids having low density is decreasing. We know yesterday I have taught you the formula, density. Low density, they are more volatile. What is the density formula, Sanjay? Density
Mass
means
by
what?
volume.
Mass by
Mass by
volume.
volume.
Puriyama? That is what. So, low density, more volatile. High density, everybody, less volatile. Puriyama, clear? Understood or not? All of you? Now, so you tell me, I will give you three substances: petrol, water, and mercury. So whose density is more? Let me see. Now, next time if you go to the petrol bunk, see that when the petrol, that person is filling the petrol, that a display you can see the density of the petrol. Have you all noticed any time? What is the density of petrol which is filling into our bike or car? Any one of you? Petrol pump. I want to know. Next time you verify, if you are getting the petrol from the petrol station, it must be 710 to 780, sorry, 760 kilogram per cubic meter. If the density is between it, then only the petrol is very good. Understand, everybody? Otherwise, the petrol is not a good petrol. It will spoil our engine. Be very careful. The density of a petrol which is filling to our cars, how much it must be? Between 710 to, all of you, 710 to 760 kilogram per cubic meter. But if you take this, that is what the petrol. So let me take the petrol is around 700 kilogram per cubic meter. Water is 1000 kilogram per cubic meter. This is water, guys. And if I take the mercury, what is the symbol of mercury, all of you? Hg. So the
Hg.
density is 13,600 kilogram per cubic meter. So can you tell me who is more volatile? Let me see who will say. Hasini, Agalya.
Petrol.
Yes. Who is more volatile?
Petrol.
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 Let me take this density is D1, this density is D2, and this density is D3. So who is greater? All of you. D3 is greater than, D2 is greater than D1. But volatile, who is more volatile? Yes, everybody.
Petrol.
Petrol is
Petrol.
more volatile. Understanding? And who is less volatile? All of you.
Mercury.
Yes,
Mercury.
that is what you have to remember. Clear? So density is higher, volatile nature will decreases. If density is more, volatile nature will decreases. Is it okay, guys? Yes, please. That is what you have to remember. Understood? All of you? Clear?
Yes, sir.
Yeah. So that is what you have to remember. How many of you understand this one? Everybody clear? So I will say volatility means you can easily say either, if I say it is the density is low, means it is easily converting into gaseous state or not? Everybody? Yes or no? The density of a substance is low. So means in the sense of it will be converting into vapor state easily or not? I want to know, all of you.
Yes, sir. It will easily convert.
That is what. So volatile nature of a liquid means what is the meaning? If I say volatile nature, all of you remember, volatile nature of a liquid, clear? Liquid, if it says, means it will gives you what, guys? How easily get understanding, how easily it gets converted into what state? Lingesh, Kishore, converted into all of
Gaseous
you.
state.
Vapor
Gaseous.
or gases.
Vapor.
That is what. So low density, low volatile in nature. High density, high volatile. Sorry, low
volatile.
density, highly volatile, and high density, low
Low
volatile.
volatile.
Clear? Opposite. Density increases, volatility decreases, and density decreases, volatility
Volatile.
increases. Is it okay,
Increases.
guys? Please respond. All of you understand? Meeting
Yes,
is
sir.
going to end.
Yes,
Please
sir.
complete it. Understand everybody till here? Sangamitrai, Hasini, Princey.
Yes, sir.
That is one. Most important one. Okay? So please make it fast. So now, for example, if I take petrol and diesel, who will evaporate faster? Diesel or petrol?